Hey guys, Mr. Bowman here. Today's learning objective is in orange and we are learning about trigonometry ratios. So trigonometry ratios, it's going to be something new to a lot of us. Before we get into the math side of things, I'm going to draw a bit of a right angle triangle here. Hopefully a better drawn one than that. And I'm just going to write in some information here. So we know this to be the right angle. And what's going to be new to us in our trigonometry questions is we're going to be given an angle as well. So I'm going to call that the given angle. And based on the right angle and the given angle, we can actually label the sides of our triangles and we can be more specific about it. So the first thing we need to be aware of is the hypotenuse. And that there is always opposite the right angle. So I'm going to call that H for hypotenuse. So opposite right angle. The next one we need to be aware of is the opposite. And this time around, we're going to look at the given angle, 40 degrees. Opposite to that is going to be the opposite. So we're going to write opposite to the given angle. And the final one we need to be aware of is the adjacent. And the adjacent sits between the right angle and the given angle. So we can see the given angle and the right angle there, and it sits between them. So in between right and given angles. So labeling the triangle, either the H, the A, or the O, is really, really important for trigonometry. So it's something we need to be really confident with. The next thing we need to be aware of is the idea of the trig ratios and their relationships. So what we're going to do is we're going to call sine angle. So that's the angle inside the triangle. And you can see above here, that would be 37. That there would be equal to the opposite divided by the hypotenuse. So that's the first trig ratio we need to be aware of, and that's the sine. Next one we need to be aware of, so we're going to have cos angle. And when you're dealing with cos, it's asking you to compare the adjacent side of the triangle with the hypotenuse side of the triangle. And then just a reminder that there would be the angle that you're given inside the triangle. The final one we need to be aware of is tan angle. And when you've asked about tan, that's asking you to compare the opposite with the adjacent. Having got all that information down, please do. It is really, really important. But we're now going to start applying these to our triangles. So what we should see, because these triangles have the same internal angles, they've both got that 37, they've both got the right angle, and if we used the 180 triangle rule to find the top angle for both, they would also be the same. Because they've got the same angle, these ratios should be the exact same for both triangles. So the first thing we need to do is we need to calculate or put in or label the sides of each of our triangles. So we'll start off with the hypotenuse. The hypotenuse is opposite the right angle. So there's the right angle, and opposite to that is the hypotenuse. And the same with this triangle, there's the right angle, opposite to that is the hypotenuse. We're now going to move on to the opposite side of our triangle, and that relates to the given angle. So the given angle, 37 degrees, opposite to that is 3 meters, so that there's the opposite, and 37 degrees on the other triangle, opposite to that is the opposite. And then finally the adjacent, that sits between the given angle and the right angle. So we've got the given angle here, right angle here. That means the 4 meter side must be the adjacent. And same on this side, 37 and right angle, 8 meters, that must be the adjacent. So what we're going to do is we're going to get into some calculations just to look at these trig ratios. So what we're going to do is we're going to try to find out, well, what is sine 37? So 37 relates to the angle we're looking at, and sine is asking us to compare the opposite and the hypotenuse. So sine 37 is going to be equal to the opposite divided by the hypotenuse, and that's going to be equal to 3 divided by 5. So we've got 3 divided by 5, and when you put that into your calculator, you're going to get 0.6. And we're going to do the same for this triangle. So the idea of a trig ratio, sine 37, should be the exact same for this triangle too, because the triangle is similar. The sides are bigger, but they should be in the same proportional, in the same ratio. So let's have a look. So we've got sine 37. That should equal to the opposite divided by the hypotenuse. The opposite is 6, and the hypotenuse is 10. So we've got 6 divided by 10, and that there is 0.6. So we can see the same numbers coming up, and that's because the triangle is proportionate to each other. The angles are the same. The sides are bigger, but they're proportionately bigger. So let's have a look at maybe the cosine ratio. Is that the same as well? So we're going to write cosine or cos 37. And don't forget, that's because it's 37, 37. And this time around, we're going to look at the adjacent compared to the hypotenuse. So cos 37 is equal to A over H. A in our case is 4. H is 5. So that's going to be 4 over 5. And you put that into your calculator, you're going to get 0.8. So cos 37 should be the exact same in this other triangle here. So let's test if that's correct. So cos 37 is equal to A over H. A is equal to 8. H is equal to 10. It's going to be 8 over 10, which is 0.8. And again, we've shown the same ratio is happening. 0.8 comes up because the triangle is proportionate. And the final one we're going to look at the tan ratio. So tan 37, that's asking you about the 37-degree angle, and it's asking you to compare the opposite and the adjacent this time. So tan 37 is equal to O over A, which is going to be equal to 3 divided by 4. So let's put that in. So what is 3 divided by 4? Put it into your calculator, you're going to get 0.75. Tan 37 should be the exact same in this triangle as well. O over A, that there is going to be equal to 6 divided by 8. And again, that equals to 0.75. And just to reiterate, that there is because the triangles, the angles are the same inside of it, but it's proportionately bigger because of the sides. So guys, hopefully you found this video on trig ratios useful. Hopefully you've seen that right angle triangles, there's a direct relationship between the angles inside the shape and the sides of the shape. And that allows us to look at some trig ratios. Thank you so much for watching, guys. Now let's get into heaps and heaps of practice.